Hi, I'm Duojia, and then this is my student card, and my student number is 217157546, and I'm recording this video for my second MECH 3409 video assignment. So for this question, we're given that the diameter of the shaft is 10 plus my student number divided by 10, which is the 46 is my two last digit. So we have diameter of the shaft is 14.6 millimeters, and for the force, the minimum one is negative 92 newtons and the maximum one is 196 newtons. And so the yield and ultimate and induced stress is given in the question. And then first of all, we need to find the Fm and Fa. So based on the equation, Fm equals to the max plus min divided by 2, which is 52 newtons. And for the Fa is max minus the mean and divided by 2 because the mean is negative, so minus a negative number is plus, so we got 144 newtons for Fa. And then for part A, we need to find the fatigue factor of safety for and the yield safety factor for the good man. And so the Ny is the yield and the Nf is the fatigue safety factor, and these are two equations that we're going to use for the part A. First of all, we need to find the stress A and stress M in order to use the formulas, right? And then, so we have two equations here. We need to find the two shear stress and the two normal stress that corresponding with the two forces, right? And then put them into one equation to combine them into one stress A prime and stress M prime. And first of all, so we know it's a cylinder, so the stress is 32 times the moment over pi d cube, and for the shear is 16 times the torque over pi d cube. And then we know that the moment is force times the distance. So the force, we have two forces, one minimum and one maximum, and then the length is just the length of the shaft, which is 350 millimeters. And then for torque is the force, the minimum force and maximum force times the Fa and Fm times the radius of the disc, which is 125 in this case. And then we find the four values here, and then we sub back this off, sub in these four values back into the equation, and then find the stress A prime and stress M prime. And then after that, we find stress A prime equals to 2,520 megapascal, and the stress M prime equals to 910.34 megapascal. And after this, we can use the formula that shows in the first page, the triangle one, to find the fatigue safety factor and the yield safety factor. So in this case, the fatigue one equals to 0.14, and then the yield is 0.22. And so both of them it shows that it will fail at the first time, right? Because it's smaller than one. And we need to plot the Goodman diagram here. And as you can see that, first of all, here is our yield stress. Here is also my yield stress. And for the Goodman line, we need to connect the induced to the ultimate. Sorry, it should be a straight line, right? And for the Gerber, which we're going to calculate on the next page, it should be a curve, right? And for the Gerber one, we just use the equation in the lecture notes, and then we have everything in here. We just sub in the numbers, and then we find the fatigue safety factor for the Gerber is 0.16, right? And then for part C, we need to compare part A and part B, which is the Gerber result and the Goodman result. So for the Gerber is a curve, and then because it's a curve, so it covers more data points and it follows the data points better. And for the Goodman, it's a straight line, so it covers less data points. It's more accurate and more reliable. And when we connect the answers in A and B, it makes sense, because for A, our number is 0.14, and for B, which is the Gerber one, is 0.16. So you find that the Gerber the number of the Gerber is bigger than the Goodman, because it gives more room. There's more tolerance in that. So even though both of them will fail, but the Goodman will fail first because the number is smaller. And then for part D, we need to find the infinite life for the good man. So this means the NF, the fatigue safety factor, is greater or equal than 1. So let's set the n equals to 1 and then work backward. So we use the fatigue equation for good man, and then because the SE is not changing, the SUT is not changing, we just sub it in, and then after simplify that, we will get equation that only has the stress A prime and stress M prime. And then in this case, because the question asking the maximum, and for the force A is 144 newtons, and for FM is 52 newtons, so we're gonna focus on FA. So we're gonna sub this number. So we're gonna focus on this equation. That's for the FA, and then because now we are trying to calculate the force. So the force is the only variable in this case, because other things are not changing. The diameter stays the same, the distance and the radius is always the same. So the only variable is the F in this case. And then after we solve for F, we have the stress A prime equals to the square root of 306.4 times F square. And then after we have this, we just plug this, and then the stress M is not changing, back into the equation right here. So in this case, the F is the only variable in this equation, and after the calculation, we have that F square equals to 30469.23, and then F equals to 174.5 newtons, and that's the answer for D. So we need to replot the load line in this case, so it will be this line, the highlighted one. And that's it for this question. Thank you for listening and watching. Have a nice day.